Hi, I'm David Parsons. I'm an academic at Massey University here in Auckland, New Zealand, and I wrote this article with three of my colleagues from Massey, Anuradha Mathrani, Teo Suzniak and Arno Leist. This article was published in IEEE Software in 2014 in a special issue on the reflective software engineer. And it's titled Coderetreats, Reflective Practice and the Game of Life. So it's about a code retreat. What is a code retreat? How can it contribute towards reflective practice? And the reference to the game of life is in fact a reference to the code kata that we used in our code retreat, which will be explained a little later. So a code retreat is a special event really for software developers to meet informally, typically for a day over the weekend, and to practice their craft. And while they do that, they're engaging in reflective practice. And the means of doing that reflective practice is to address a single programming problem over time with multiple coding partners using pair programming and specific design constraints. So we ran an experiment with a group of our final year students to find out how well code retreats could indeed encourage self-reflection and also some other features such as motivation and skills development. One of the questions that we often need to address as software engineers is how do we improve skills and techniques? How can software engineers rehearse and reflect on their craft? So one of the analogies that's often used is that of the musician. So many years ago when I did a music degree and I played the clarinet, if I was preparing to play a concert piece, I wouldn't only play that piece. I would also use scales. I would use studies. And I might approach the same scale from many different angles. I might play the same scale staccato or legato. I might play it quickly or slowly. I might play it in triplets. I might play it loudly or softly. So I would approach the same material from many different angles, and by doing so I would develop my technique and increase my understanding of how to approach a particular piece of music. So what are the scales and studies of software? Well, Dave Thomas hosts a site called codekata.com, and he's been writing these code katas for quite a long time. A code kata is simply a small exercise in coding that you can approach from many different angles. So you understand the problem. Your task then is to understand different ways of finding a solution. And over time, Dave Thomas has developed many different katas, which are all part of his catalogue hosted on this website. So what's the relationship between a code kata and a code retreat? Well, a code retreat uses a code kata, but in addition it does many more things. For example, it provides you with an opportunity to work with other people, which working on your own with a single kata does not allow you to do. It's now quite a large community. The names of the four guys listed at the top here are the ones who started the whole idea off back in 2009, but that's not to take away from the many other people who are now extensively involved in the Code Retreat network. And indeed, they've reached the stage where they now run a global day of Code Retreat, involving developers from all over the world working on Code Retreats in a single day. So Code Retreats focus really on design fundamentals. They focus on practicing basic principles of modular and object-oriented design. And in order to do that, we focus on the XP simplicity rules, which are test-driven development, refactoring to remove duplication, making sure that our code is cohesive and self-documenting, so it expresses its requirements clearly, and that it contains no unnecessary features. The famous YAGNI, or you ain't gonna need it, comment from the various agile methods. So a Code Retreat structure is listed on the Code Retreat website. So there's a recommended structure. Now it doesn't mean that you have to follow this, but this is the normal approach. So there's a code kata, which is normally Conway's game of life, and I'll talk about that in a while, just in case you're not already familiar with that particular programming problem. A code retreat consists of 5 or 6 45-minute coding sessions, so basically that'll take you a whole day by the time you've built in a few breaks and lunch and so on. Pair programming and test-driven development are both used. And after each session, code is deleted and partners swapped, so all the work that you've done in a particular session is thrown away and you start again with a different partner. There's no expectation that you'll actually write a complete solution in any session. This is not about finishing a particular product, it's about thinking about design. And in order to make this interesting and provide different perspectives, a number of constraints can be applied in the different sessions. So each time you address the problem, you're addressing it from a different angle, with a different partner, with a new point of view. So what do code retreats offer? Well, they offer a change of problem setting so that you can get different perspectives on the same problem and approach your design from different ways. Because there's a number of different cycles, they allow you to experience different ways of looking at the same problem and reflect on it in action. You can have reflective conversations with and learn from the others that you work with, the various pairs that you work with over a day, and they may have very different ideas to you. There's also the concept of deliberate practice, which comes from an article by Todd Sedano, where he talks about we shouldn't just practice the things we're already good at, we need to practice the things that we're not so good at. And that's what a code retreat's very good at doing, because it gives us quite tricky problems that we might not otherwise put in front of ourselves. And it's about innovation and exploration, perhaps the opposite of normal software engineering, where what we're constantly trying to do is to reuse as much as possible, to not reinvent the wheel. A code retreat lets us be innovative. It lets us be explorative in a way that maybe daily software engineering does not. So I think it's probably important to briefly explain the game of life simulation for those who may not be familiar with it already. It's quite a well-known simulation, developed by John Conway, and it's often seen as a useful kata. And it's a useful kata, I guess, because it's conceptually simple, but there are many different ways of approaching the problem. So in this simulation, cells exist in a conceptually infinite grid in 2 dimensions. So each cell is only a representation of something that has a binary state. So a cell is either alive or dead, and that's really all we need to know about it. So in these slides I've simply represented life and death by green and red disks. So at the beginning of the simulation there's going to be a number of cells, and each one of those cells must be initialized as either alive or dead. And then there's a series of generations that take place that will lead to state transitions. So in each generation, each cell will either remain in its current state, or it will transition to its other possible state. So these state transitions are actually dependent on the states of the 8 neighbouring cells. So there are 4 simple rules really: underpopulation, next generation, overcrowding and reproduction, and I'll briefly explain what those are. So underpopulation, a live cell with less than 2 live neighbours dies. So this particular example here, the cell in the middle is the one we're interested in, only has 1 live neighbour. And so at the next generation it will die. However, if the cell has 2 or 3 live neighbours, and this particular example has 2, it will live on. If there are too many neighbours, more than 3, as in this case where we have 4, the cell will die. And finally, reproduction. If a dead cell has exactly 3 live neighbours, it will become alive. So this is the kata. This is the kata that needs to be addressed by the participants in a code retreat. And as I mentioned before, they're not expected to build a solution to this problem. It's all about thinking about ways that you might approach the design of something that would simulate Conway's game of life. This is the kind of thing they might end up if they had a UI, which typically they don't in a Coderetreat. We're really looking at the underlying model, but these are just some examples that come from Wikipedia, and you can simply see the way that a set of cells might evolve over time through a series of generations. So that's enough about Coderetreats in general. What did we actually do? Well, we developed a study to explore how a Coderetreat can support reflective practice. We gathered some empirical data on how the code creation evolves, and we gathered some survey data on the experiences of our programmers, who in fact were our students. So we had 36 students. They were software architecture students, and we gave them a Coderetreat. They were using Visual Studio, a mix of languages. It could have been C# or VB. There's nothing in a Coderetreat that says it has to be a single language. In fact, often they're an interesting mix of languages. We followed a standard 5-session structure, and we've applied some common design constraints that are commonly used, and we took these from the Coderetreat website in sessions 2 to 5. So the normal thing that we do in a Coderetreat is we have no constraints in session 1, and then we introduce different constraints over the different sessions. So we took some fairly simple ones. In session 2 we applied the ping pong constraint, which is very simple. It just ensures that the pair programmers swap their roles. In the next session we used silent pairing, known as the mute design constraint. So it's really designed to help students or participants write code that speaks clearly. A rather more challenging one in session 4, which was no arrays. What we tend to find in this Coderetreat with the game of life is that a common approach is simply to create a 2-dimensional grid and put the cells inside it. And if you tell the participants they can't use any arrays, it rather forces them to rethink anything they might have assumed about the design. And then finally we added a new requirement, which was to track the generations, and that was something that would probably undermine most design assumptions that people had made in their previous sessions. So the point about these constraints, of course, is to force the participants to not just do the same thing over and over again, but learn new approaches to design. So it's all very well saying we're going to run a Coderetreat, but what were we trying to measure? Well, we're trying to measure reflective practice to some extent. So we had a look at some previous work, and people measure reflective practice in different ways. For example, they'll look at what events occur. They might look at how long people spend doing certain things, how they use resources. They might look at their direct feedback, for example, forum access, posts and so on. They might look at the relative time spent on different activities and record various things with software tools. So in our particular context we chose a number of ways related to some of these ideas about how we might try to measure reflective practice. So we decided we'd use software tools to store and analyze some code, that we would count event instances. So we would, in our case, we would look at test code and the assertions inside that test code. We would see how resources were being used, the test resources, in terms of measuring test quality. We would look at test frequency, if you like, the relative time spent achieving useful results, and we would get direct feedback by administering online surveys. So somewhat different perhaps to some previous studies, but tailored towards our particular interest. So one of the things we did was analyze the code that was written. Now in a normal Coderetreat the code is thrown away between sessions, and indeed from the students' perspective the code was thrown away. They weren't allowed to use it again, but we did log it on the server, and so we could go back and have a look at it. So we had a look at what happened over the 5 sessions in terms of both the quantity and the quality of the code. So in terms of quantity we looked at the number of test methods that were written, and within those how many significant assertions were being made. And we also looked at quality. We took as our quality measure Bill Wake's pattern, which is the 3A pattern, that each test should arrange, act and assert, and part of that is that we shouldn't have lots of assertions in a single test. And we basically compared how progress evolved from the first to the last session. So in that particular analysis we just looked at the first session and the final session. So what about our quantitative results? Well, we saw an encouraging increase in both the number of assertions and the number of test methods over the various iterations. Now you'll note that in the final session we actually had a small drop in both of those. Now that's probably explainable by the fact that we completely changed the requirements, so it meant that the students had to kind of, if you like, throw away almost everything they'd done before and almost start with a clean slate, which perhaps slowed them down a little bit. But nevertheless, you can still see that there's a definite increase still from the first session to the last session, even though it was much more challenging. So what about test quality? Well, we saw significant improvements here as well. In the first session, only half the pairs were writing tests that had any utility at all, and of those only half wrote tests that were really compliant with the 3A pattern. About a third of all the pairs were only writing meaningless stubs or things that maybe have been generated by the test framework but didn't really do anything with them, and some of them couldn't even do that, couldn't even generate anything from the test framework. By the time we got to the last session, we saw a major improvement. All but two of the pairs were producing 3A compliant test suites. Really only a small number were still perhaps not writing quality tests, maybe too many assertions, and there was only a handful writing inconclusive tests, so we can basically say that the quality of the tests improved a great deal over our sessions. Now we also administered some surveys. We had a session survey, and we administered this at the end of every single session, so we basically administered this 5 times, and each time we asked the same question. What was the first thing that you tested in this session, and why did you choose that particular test? What we were trying to find out was whether people kind of stuck in their ways, or whether they adapted to thinking about the problem from different perspectives. So these are our results. The numbers in these tables are quite small, so we often found that the explanations that were written in the survey weren't really clear enough for us to really understand what was going on. So we have to take these results with a little bit of a pinch of salt. But we did kind of see that the test-driven design adapted to session constraints. I've specifically used the term test-driven design here rather than test-driven development, on the assumption that TDD really is a design approach, and what we were hoping people would do would be to leverage the test to think about the design in different ways. And I think to some extent the table shows that that did happen. If we look at each session, which are the rows, we can see that initially there was a big focus on the constructor and the cell life. We did seem to see a little bit of an evolution over time of people trying out different things, particularly when we got to number 4, where there was a complete change of the problem and the data structure was the focus. And once again in session 5, when the new requirement became the focus, we see some major changes in the way that people were approaching the problem. So what we didn't see was that we provided a new constraint, but people just carried on sticking with the familiar. So we did try and hopefully see that there was some change in the way that people addressed the problem. We also had a final survey, and this was quite a long web-based survey that looked at a number of different features. So we were trying to find out about different aspects of self-reflection. We asked some quantitative structured questions. For example, we used some Likert scale questions, and we also asked some qualitative free text response questions. Now, Coderetreats have a standard set of questions. You can find these on the Coderetreat website, and these are: what, if anything, did you learn today? What, if anything, surprised you today? And what, if anything, will you do differently in the future? So I've just chosen a few, if you like, exemplar responses that we got to these questions from the student questionnaires. So what about the things that the students learned? Well, we found that quite a few people were expressing that they'd learnt quite a lot about testing, writing tests, and the test-driven development process. So the comment at the top there about problem solving, and also use of the constraints. It's quite a common response to say that, you know, I learnt quite a lot of stuff about testing. The second one's interesting too. I learned a better understanding of starting off programming. I struggle with finding where to begin. And I think this is really quite insightful because it's really what test-driven development is all about. Where do you start with a problem? If you know that the first thing you do is write a test, well, maybe that's a really useful insight from the perspective of this student. And another aspect was how to write tests at all stages of code. So perhaps this student had a sort of more traditional view of testing as something you do at the end rather than driving your development all the way through with tests. So we certainly saw some insights being developed out of this particular process. What about surprises? Well, we normally expect the surprises to be the constraints, and certainly that came up a lot. The first one there, you asked us to write the program without arrays, sad face. Obviously being presented with these challenges was a big surprise to some of the students. The second one there again, the no talking challenge. I was expecting coding difficulties rather than communication difficulties. So again, springing these surprises really does put the students out of their comfort zone into an area where they can learn something new. And some other insights, how many different ways you can do the same thing. Again, underlining the value of doing this multiple approach to the same problem. And I quite like the one at the end, although perhaps it's a bit depressing if you think about it. Finally understanding something this semester. Well, I suppose that's perhaps a positive. And the last one, what will you do differently in the future? Quite a few of the students felt they should have prepared more. Maybe that's sort of missing the point, but maybe they felt that they would have liked to have done better, so maybe they could have got more out of it. Test when there is only skeletal low amounts of code. I think that's a really interesting response. That really shows that we brought over the idea of how important testing is at an early stage of development. And of course, one of the aspects of Coderetreats is to try and encourage people to think more about those simple designs, and a nice example of that is looking more closely to the problem and modularize. So clearly that idea of the design was being brought in by the Coderetreat. I'm not sure how valuable the last comment is, but I would sleep more the night before. Truth. Again, I think it's a positive response in a way, because both the first and the last comment here kind of indicate that the students would have liked to have performed better perhaps than they felt they actually did. Now, Barry Zimmerman's written quite a bit about self-reflection, and we chose some of his basic concepts for our questions as well. So we addressed mastery, previous performance, normative criteria, collaborative criteria, and alignment of poor results with processes that can be controlled. So I'm just going to go through these questions and explain what each one's trying to measure. So mastery is really just comparing yourself to what you think is perhaps a gold standard. How do you think you compare yourself to what you see as the levels that you might choose to attain? Now, it's not surprising that none of our students felt they were experts. After all, none of them are professional software developers. But we saw a fairly encouraging response at the end in terms of the mastery over this particular process. So the question wasn't about mastery of software engineering in general, it was mastery of what we'd been doing inside the Coderetreat. And perhaps the most encouraging thing here is that only one of the students at the end of the Coderetreat still felt that they were a novice. Perhaps more encouraging that in terms of previous performance, that is, how much did the Coderetreat actually help the students compared to where they were when they started, which is a little bit more insightful perhaps than mastery, because mastery could come from somewhere else, but we're looking here at specifically what happened in the Coderetreat. And what's really encouraging here is that some students made what they thought was very significant progress, and all of them made some progress, even the person who still felt they were a novice. So that was a very encouraging result. The other criteria, normative criteria is just comparing yourself with others, and we found that that was a realistic assessment, that the assessment was pretty much average. People compared themselves to other students in a way that was probably realistic. Collaborative criteria, we asked them about how they felt in the pair programming. They all seemed to be comfortable with it. Only 6 were more comfortable in the role of driver rather than navigator, but that may just reflect their lack of previous experience. We asked them to order some causes of difficulty, and this was where we were trying to find out how they aligned processes and results. Now, in asking this question, ideally what you want to find out is whether the students see things that are controllable as being more important than the things that are perhaps out of their control. So what you don't want to see is that they find that their own skills and experience are the biggest problem. We were reasonably encouraged by the responses here. We can see that the framework and the programming language, which if you like are external controllable aspects of the process, were bigger causes of difficulty than lack of skill. And perhaps more encouragingly, the working with others was seen as the least difficult thing to do. So we were reasonably encouraged by this. It was also worth noting that the difference between the lack of skills and experience and the constraints in terms of the responses was very, very small. We also asked students about how they develop their skills in writing tests, because that's really one of the core skills in a code retreat, and we did see a definite improvement from an average of 4.66 to 5.64. So definitely some improvement in writing tests. We also at the end asked some open questions about other comments, so these are the kinds of things we got back. A good activity preparing the students. A lot of them were pleasantly surprised how useful it was, and also how enjoyable it was. So the general feedback was very, very positive in terms of the experience, even though it's a long time to commit. It's many hours, much longer than a normal lab session, which is normally a maximum of maybe 2 hours, and we had them in there for 5 45-minute sessions. It was a long session. And also this one at the end, the more we did, the easier it got, and getting different ideas was good. So generally speaking, we got some pretty good feedback. So what was our conclusion? Well, overall we felt that the code retreat had lots of positive outcomes. There was definitely evidence of self-reflection going on. There was a lot of collaborative effort, learning from each other, a lot of positive attitudes towards collaboration. There was definitely improved conceptual understanding. We could tell from analysing the code that there was definitely an improvement over time in how students approach the problem, how well they approach the problem, and the way that they developed the code through a test-driven process. And we definitely felt that there was progress towards mastery. So even though none of the students felt that they were yet masters of their craft, they were certainly moving towards achieving that. So what's our future work? Well, I think there's really two things that we'd like to do next. One is to try and assess what goes on in professional code retreats, because it's all very well doing a code retreat with some students and finding out what goes on, but of course most people who are doing code retreats are not students, they are in fact professional developers. So to what extent is a code retreat being beneficial to a professional developer? And perhaps more importantly, over time we'd like to propose new ways to enhance the value of code retreats. So we feel that if we can analyse what goes on in a code retreat, if we can look at what works, maybe what doesn't work quite so well, perhaps we can find ways to propose new ways of customizing code retreats, or providing similar activities that are like code retreats but perhaps focus on slightly different ways of doing reflective practice, and maybe finding new ways to challenge software developers to develop their skills and become more reflective. So really one thing that we'd like to do is to just promote the whole idea of code retreats. Now this particular map comes from the Code Retreat website. This is the Code Retreat, the Global Day of Code Retreat map, and you can see all of the places that participated in the Global Day. There were 2 in New Zealand. I attended the one in Wellington, and one of my colleagues, Anurada, attended the one in Auckland. And you can see that there are a lot indeed of people participating in particularly Europe and the United States. But we think there's a lot of potential for code retreats, and not just for professional developers, but also for educators. So if we achieve nothing else with this particular article, what I hope we can achieve is that it increases people's interest in and knowledge about code retreats, and encourages them either to participate in a code retreat or indeed to run one for themselves. Thank you.